Hi, guys. It has been a day. We are now on day, I don't know, 482 of this coronavirus lockdown. No, I'm just kidding. It's only like day three, but I am over it. It's actually just the end of day two right now, but my heat went out and I had to cancel Eloise's trip. And now I have to buy a new furnace and a new air conditioner, and things are crazy over here. And then I actually just recorded this whole video already and then found out that the microphone wasn't working. So now I've spent an hour fixing the microphone and now I'm going to try again. But on the upside, do you guys like my makeup? Eloise did my eyes for me. She was going to do my whole face, but she got bored. And so that's why my lips now look super pasty. But anyway, if you like my makeup, like and comment down below. Just no. Okay, anyway, let's take care of these notes. They should be super quick, but I do want to warn you it's super gruesome this time. So, I mean, if you want to not listen to me talk because it's easier, well, I mean, it's always easier to not listen to me talk, but if you want to not hear me explain, there's too many images or whatever, see what you can do. Let me know if there's an issue. But try to think of this as all blood that's just like, like hanging out somewhere. Didn't really come from, any human or anything. It's just blood like on the table or, moving around. Like Dexter in a lab kind of thing. Maybe that'll make it a little bit less upsetting. So I'm really sorry that you're having to like sit in your living room and listen to me talk about this, but we'll try to knock this out pretty quickly. I will also say it's after midnight and the little beasties are still running around. Eloise has the foster dog outside, and so they could come bursting through at any moment. But at any rate, let's take care of some terminology. So the first is that there's one kind of blood stain that are called passive blood stains. So this is like in English when you talk about passive voice and active voice. And passive voice means that you're talking about something that just sort of something happens to that object. So the ball got kicked. So the ball was just sitting there being a ball and it got kicked. Passive blood stains are blood stains that happen because the blood is just sort of there and something happens to it. So blood clots, like when platelets come and clot the blood up, drops, so just literally gravity just pulling it down, flows, same kind of thing, pooling, so a pile of blood that kind of oozes out. Those are all passive blood stains. The blood isn't really actively doing anything. It's just sort of having general physics act upon it. So these are passive blood drops, which you can tell because they're perfect circles. So they're just dropping from above. We'll talk more about that a little bit later. So part of this is actually active, but we're going to talk about the part that's passive right now. And the passive are these drips. So the blood hit this wall and then dripped down. And so these drips are the passive part of the blood spatter here. Just all the drips that are coming down, that's all passive. And then this is a pool, but I like this particular picture of pooled blood because you've got a little ET finger there. All right, then there are transfer blood stains. So there are wipes, swipes, and pattern transfers. So wipes and swipes are tough to remember which one is which. I'm going to tell you the difference right now. It's going to make sense to you right now, and you're going to be like, oh, yeah, cool, that sounds great. This is the kind of thing that 15 minutes from now, if I were to ask you about it, you would not remember what the difference is. If I ask you about it when we come back, you're not going to know the difference. So you need to make sure that you put a little star next to it or something so that you go back over it and over it and over it and over and over it to make sure you understand the difference between wipes and swipes. So we're going to start with wipes. So wipes happen when the blood is pre-existing on a surface and some object comes and moves through the blood. So the blood is just sitting there, and an object moves through the blood that's already sitting on that surface. So if you look at this picture right here, you can see that there's this outline here where the blood drop was sitting and started to dry a little bit. And so it formed that little circle around the edges. And then some object came and moved through it. So that's a wipe. So if you think about it as wiping off the countertop, all of the crumbs and goo and grossness are already sitting on your countertop, and you come by and you wipe the countertop off, okay? The other thing is swipes. Swipes happen when blood is transferred from a moving bloody object onto another object. So the blood is actually on the moving surface, okay? So if you had a sponge that was covered in blood and then you moved that across your countertop, first of all, gross, why would you do that? But second of all, that would be a swipe, okay? So in this picture, you can see that there are, it looks like fingerprints. And so the 4 fingers have blood on them and swipe down. So if the blood is on the moving object, you have a swipe. If the blood is on the passive, just hanging out object, you have a wipe. And then the third thing was pattern transfers. So That's something that we talked about when we talked about the O.J. Simpson case, and they talked about the socks. And the socks were packed together. So the first problem was that blood from one sock could have gone onto the other sock, or could have gone through the sock. The blood was also, remember, they were packaged up, and the blood was wet when they packaged them. And the reason they know that is because when they closed up that paper bindle around it, they opened up the paper bindle around it, and you could see little outlines of those blood drops on the paper. And the only way that happens is if the pattern transfers onto the paper. Okay, so that's a pattern transfer. Then there are projected or impact blood stains. So this is our active blood spatter. Okay, so we don't really talk about active though. We talk about projected or impact blood stains. So there's spatter, there's splashes, there's Castoff, there are arterial spurts or arterial gushes, you'll hear them called. So first things first, I think I may have told you this already, but it is spatter, not splatter. Spatter, not splatter. Do not put an L in that word. It makes the blood experts very angry. Spatter, not splatter. And that's the result of projected blood hitting a target. So now blood that's actually flying through the air, not just dripping, not just pooling, not just dropping down. This is blood that's actually actively flying through the air and hitting a target. Okay. So there's forward spatter, and forward spatter comes from droplets of blood that are moving away from the object, creating the impact. So we're going to imagine that I just have a pool of blood right here. I don't know why I have a pool of blood right here, but I'm going to come in and I'm going to bring my hand down onto that pool of blood. And when I do that, my hand is coming in from this side, and the blood is going to push away that way. So we're going to have a splash of blood that goes that way. That's the forward spatter. So hand coming this way, blood going that same direction. That's forward spatter. Now, I think you know that if I smack my hand down into this blood, not only is the blood going to go this way, but some of it's going to splash back up onto my hand. And that's called back spatter. So my hand comes in this way, forward spatter goes that way, but back spatter is going to come back this way and get onto my hand. Now, typically there's going to be way more forward spatter than there is back spatter. Back spatter is going to be a much smaller amount because all the momentum was coming forward and pushing the blood in that direction. Okay, so this way, forward spatter, back spatter. Here's another diagram to show you. So here is our pool of blood, say, and we've got the direction of forces coming this way. So whatever comes in hits here, forward spatter blood goes this way, back spatter blood goes this way. Okay. All right, Castoff then is going to happen if, let's say now my hand is bloody, okay, and my hand swings back, okay? So when my bloody hand swings back, there's blood all over my hand, and some of that blood is going to fling up and hit the ceiling. Some of it's going to fling back and hit the wall over there. If there's enough, some of it might hit the wall or the door behind me, okay? And so it's going to be blood that's literally cast off of my hand as I come back. And so I come forward, forward spatter, back spatter. As I pull back again, Castoff is going to go this way. If I come forward again, forward spatter, back spatter, and then Castoff again, okay? So Castoff looks like this, where you've got big, little, and there's some directionality here, which I'll talk to you about later. So this is Castoff. So whatever it was flinging back this way. So they were hitting here and then flinging back this way. And so you've got most of the blood here, and then as they flung, less of the blood came off their hand, or whatever the object was, and you've got that motion that you can sort of see there in the image. And then there are arterial spurts. So remember that you have arteries and veins, and you have capillaries as well, but you have arteries and veins. Arteries are where the blood pushes out from your heart into the arteries. Then your blood is going to coast, and it's going to go through capillaries, and then it's going to come back to your heart through veins. So by the time blood is moving through veins, blood doesn't have a lot of momentum. But as blood is moving through arteries, it's got that really big push from your heart. And so you're going to get a squeeze and the blood is going to gush through the artery. So if you were to cut an artery, every time the heart pumps, you're going to get blood that oozes out. And so you're going to get squeeze, gush, squeeze, gush, squeeze, gush. And so an arterial spurt is going to be a blood spatter pattern that looks like that. You're going to be able to see the different spurts or the different like sets of gushes that are coming out. And so this is an example of an arterial spurt. So you have a gush and a gush and a gush and a gush and a gush. So each one of these is basically a lub dub of the heart. And then because it was so much blood, you've got the passive blood where you've got the drips that are happening here. All right, void. So a void should be really easy for you to learn about. So this is an indicator that there was some kind of secondary object that came between the spatter and whatever the final target was. It's going to leave an outline or a shadow. And so right now there should be alarm bells going off in your head. And you should be saying, oh my God, that sounds exactly like something I learned about before. So stop for a second and ask yourself, what is this just like that you learned about before? Okay, hopefully you said a heat shadow from when we did our fire and explosives unit, and that is what it is. So if we look at this, take a second and look, and you can see that there is a white space in this general area that did not get hit by all of the rest of this blood spatter. And now as you look at it, see if you can figure out what that object was. What object was probably in that space blocking that blood from hitting that white surface. So again, pause for a second, hit pause, literally, if you need to, and see if you can come up with an idea of what that object was. All right, let's see what you came up with. Hopefully what you came up with was, dun, 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 a crescent wrench. So if you look, here is where the handle of the crescent wrench would be. Here is that top curve. Again, here's the top curve here. Here's the bottom curve. Here's the bottom curve. And then you've got the jaws, the sort of mouth part of the wrench is here. Now, obviously, it wasn't this specific wrench because this is a cartoon wrench, but that's a void, and it works just like a heat shadow. It can tell you that something was there before, but isn't there now. And so if you've got a void and there's blood spatter around it, you should be asking, what was there that's now been moved that I'm wondering about? All right, so now if we're going to start talking about individual blood drops, so rather than whole big patterns, we're going to now zero in on individual blood drops. An individual blood drop might have, it's not always going to have, but it might have a satellite or a spine. And these are secondary patterns that are going to come out of the main droplet. So spines are straight lines, and they're going to be connected to the droplet. Satellites are smaller droplets, and they're typically disconnected from the main droplet. Now, there might be a spine connecting the two, like the example I'm about to show you. Okay, but let's take a look right here. So here's our main droplet right here, okay? And here's our straight line connected to it. So this is a spine right here. And then a satellite is a smaller droplet disconnected. So this is a satellite. And actually, here's another little baby satellite with another little baby spine there. Okay, so again, main droplet here, spine here, satellite here, baby spine, baby satellite. Don't go call it a baby spine and a baby satellite if you go to a job in forensics. People will laugh. Okay, so spines are straight lines coming out of the main drop. Satellites are actual separate drops because what happens is the blood hits and then a piece of it will actually like jump and it leaves a little tail behind it. And so what satellites and spines can tell you is what direction the blood was traveling with the object. So when we went back and looked at that Castoff stain, and you can go back and look at it if you want, I was able to tell you, oh, look, the blood was moving this direction because that's the direction that the satellites and spines were. And so the satellites and spines are pointing. So on this particular image, the blood came in, it hit here, and then some of it continued moving this direction. So this blood was moving this direction when it came in and hit. So satellites and spines can show you directionality of blood. All right, angle of impact, figuring out angle of impact. This is going to be so easy. You know why it's going to be easy? Because you did such a good job in one of our previous units. And when you did a good job in that previous unit, that's going to make it so you can do a good job here. Yay, you're welcome, you of, you know, I don't know how many months ago. At any rate, when blood is cast at an angle, the leading edge of the droplet ends up elongated relative to the back or trailing edge, and you're going to end up with an ellipse. The more circular the drop, the closer the angle of impact is to 90 degrees. The more elliptical, the smaller the angle of impact. Hopefully, like all sorts of bells are going off in your head right now. So if we look at some pictures of blood drops here, this is the one that's closest to a nice round circle. And so this is the one that's closest to 90 degrees. Now it's actually pretty far from 90 degrees, it's 50 degrees. But it is very different from this one over 10 degrees, which is way super elliptical. and has a much smaller angle of impact. So what if we wanted to calculate the angle of impact? What do you think you would do? Again, hit pause and ask yourself, if you were forced right now, if I was like, this is your final exam, right this instant, find the angle of impact, what would you do? All right, hopefully what you said is that you would take the sine of theta and put that equal to the minor over the major. Because you know what? This is exactly like doing bullet holes. This works exactly the same way. So you just figure out the minor and the major, sine of theta, that angle of impact is equal to that, and do the math, and you're good to go. There is actually one teeny tiny little thing that's different. If you look at this blood drop in particular, it's the easiest to kind of see it. So keep in mind that our blood drops need to be ellipses. They need to not be these irregular shapes. And so you've got a nice rounded edge here at the top of this ellipse. But then over here, you have this like pointy edge where we then lead out to the spine. When you measure, we do not want to measure from here all the way down to here. That's a bad idea because this was not part of the original impact. The original impact ended around here. So keep in mind an ellipse is symmetrical. So if it helps, find what you think is about the center point and then sort of imagine it as being sandwiched over and say, okay, right here is probably where I want to measure to, not all the way to here. That's the only thing that's tricky, is making sure that when you do the major, that you're actually doing the major and not a whole bunch of extra stuff too. All right, now area of origin. If you've got a bunch of blood stains, you might be able to work backward to a place where all of the blood stains paths converge. So when I brought my hand in and I smacked that pile of blood, a bunch of different blood drops were going to go off. And if we looked at each of those different blood drops and where they ended up, we would be able to figure out where my hand was when my hand smacked that big pool of blood. Okay, so we could work backwards from those blood drops that hit. That's going to help us find the area of origin. So with a fire, we talk about point of origin, but with blood, we talk about area of origin, because typically we're not talking about one really specific place. We're talking about a general area. Unfortunately, when blood starts spattering around a crime scene, it's typically not because of one single impact. There's probably multiple impacts. Okay, so we can do this using string and lasers. You've probably seen that on TV. It looks really cool. I'm going to show you a picture in a minute. So again, just brace yourself for a picture of actual blood in an actual scene. And it's going to show you what it looks like when we string blood. So what you're looking at, let me just orient you here. What you're looking at is you're looking down. You have a bird's eye view and you're looking down on a mattress in somebody's bed. So this is the headboard up against the wall. And then this is the mattress. And then they've got a cluster of blood spatters here, a cluster of blood spatters here, a cluster here, and a cluster here. My guess is there were multiple impacts that caused these different blood spatters here. But they used different colors of string to pull back. And so they came to this blood spatter. And what they did is one little blood spatter at a time. They first figured out what direction it was moving. And so it was probably moving this direction. And so they put the string on and they pulled the string back this way. But then they figured out the angle of impact off of the wall. And so once they figured out the angle of impact off of the wall, then they knew, okay, we should pull it back this way, or no, we should pull it back this way, or no, we've got to pull it out this way. So they could figure out what that angle was. And then they pulled it back to, you know, a rather distant point. So they brought it all the way back here. Okay. And they did that with every single one of these. So they did that sine of theta calculation with every single one of these little blood spatters that were here. And then they looked at the directionality based on the spines and the satellites. And then they put the string in and then they pulled the string backwards. And when that happened, they ended up with this area of origin right here, where they found this is probably where the victim was when whatever injury it was occurred. So you can kind of get an idea, again, in reconstructing a crime of what happened. All right, so that is all I have for you in these notes. You're going to do a lot more reading, which is probably better than these vivid pictures. But this is what I've got for you. So hit me up, ask me questions if you've got them.